everyone, I'm Sejal Sonawane and my group members are Tanisha, Sethi, Islumeet, Kaur and Bhavna Rathod. Our subject of uh, presentation is Sign Language Recognition System. This is the outline of our report: introduction, motivation, aim and objectives, problem statement, literature survey, scope of the project, system requirements, systems architecture, model description, mathematical model, project analysis and design, then diagrams, data flow diagram, UML diagrams, then methodology, applications, conclusions, and references. Introduction. Sign language is the only tool of communication for the people who is not able to speak and hear anything. Sign language is a boon for the physical challenged people to express their thoughts and emotions. In this work, a novel scheme of sign language recognition has been proposed for identifying the alphabets and gestures in sign language. With the help of computer vision and neural networks, we can detect the signs and give the respective text output. The sign language is used widely by people who are hearing impaired as a medium for communication. A sign language is nothing but composed of various gestures formed by different shapes of hands, its movements, orientations, as well as our facial expressions. There are around 466 million people worldwide with hearing loss, and 34 million of these are children. Deaf people have very little or no hearing ability. They use sign language for communication. People use different sign languages in different parts of the world. There are many other sign languages other than Indian sign language. Like in Arab there is Arabic sign language, then there is Bangladeshi sign language or American sign language, etc. Compared to spoken languages, they are very less in number, sign languages. India has its own sign language by the name Indian Sign Language, as I said earlier. In developing countries, there are only very few schools for deaf students. Unemployment rate among adults with hearing loss are very high in developing countries because of loss in communication. Data from Ethnologue states that among deaf population in India, which is about 1% of total population, literacy rate and number of children attending school is very less. It goes on to state that official recognition of sign languages, increasing the availability of interpreters and providing transcription in sign languages greatly improve accessibility. Signs in sign languages are the equivalent of words in spoken languages. Sign languages appear to favor. Motivation behind this project is to lessen the communication gap between the hearing impaired people and people with hearing abilities. Since communication is having a great impact in every domain, and how it is considered the meaning of the thoughts and expressions that attracts the researchers to bridge this gap for every living being. That's why aim of our project is, the objective of this project is to identify the symbolic expression through images and convert them into speech or text, so that the communication gap between a person with no physical disability and a specially challenged person can be easily bridged. So we can smoothen the communication between both parts of the society. Problem statement is to create a system where communication between every human, be it hearing impaired, vision impaired, or people with no physical disability is possible. To create a system where sign language is converted into text and speech and vice versa. Literature survey. Compared to spoken languages, sign language are very less in number. To add those in need and to encourage the use of sign language, researches have been carried out and now projects and systems are created. And for our survey, we chose three papers, like three previous researches for our survey. First is Lance Fernandez, Prathamesh Darvi, and Akash Janarkar used HC05 Bluetooth module to facilitate wireless communication and CNN in their research paper, Convolution Neural Network Based Bidirectional Sign Language Translation System. The CNN was trained to capture features from hand. They have achieved an accuracy of 91.7% on cross-validation, containing different users with different background from the training set, and testing accuracy of 95.68%. But it contained users and backgrounds from the training set. But they have drawbacks. The drawbacks of this system were that the system couldn't differentiate between 2 and 3, from 2 from V and 3 from W, because we use same sign for 2 and as well as V. So that's why system couldn't differentiate between 2 and V and 3 and W. Next is recognition of sign language symbols using templates by Deepika Pahuja and Sarika Jain. In this project, they used the non-parametric approach for skin color detection, and the image processing toolbox of MATLAB. This had a success rate of 78%, with the only limitation being that due to recognizing sign language symbols in static images, the vocabulary of the system was limited. Then Sign Language Interpreter System, an alternative system for machine learning by Salma Asmeldin and Mohammad Abdul Ghani. They use gloves with sensors, and it uses Arduino for receiving readings. But they had limitation that they cannot detect the curves of the fingers properly, and hence prediction is not 100% accurate. And however, given the limitation of having such delicate sensors and gloves makes it inconvenient to use.
Scope of the project. This system can be used during video conferences or reception desks to allow signing people to speak with people who don't know Indian Sign Language. Next slide. So these are the system requirements. The hardware resources required are processor Core i3, RAM 8 GB or higher, hard disk 10 GB or higher, camera good quality 3 megapixels, software resources required, operating system Windows, Mac, Linux, SDK, OpenCV, TensorFlow, Keras, NumPy. Preferred technology for user interface we have used HTML, CSS and Flask, and for backend we have used Python. Next slide. This is our system architecture. In this, first the user will do the hand gestures in front of the camera. The camera will take that as input and process it, and it will compare the hand gestures with the words kept in the dictionary. Then it will display at the end that which letter the user is displaying as hand gestures. Next slide. This is our module description. Our application is made up of 3 major parts. Sign to text or speech application. In this, the function program will try to recognize the gestures executed in front of the camera, and it will show the output as text or speech. Next module is text or speech to sign application, and next is text to speech application. Next slide. So this is our mathematical model. Let S be the solution set for the given problem statement. The user will do the required input, then the computer will process and it will produce some output which will be either success or failure. Next slide. This is the input. Process will be done by CNN, that is convolutional neural network, and output will be prediction or accuracy, based on prediction or accuracy. Next slide. Success and failure. Success if the if the system changes the required mode like sign to text, then it will be considered as a success. And in failure, both the users should be present at the same time. If one user is not present, then system will be failed. Then the system might not know all the signs and may not be able to convert it into text. Next is the system might not be able to capture the signs accurately if it is blur. Next slide.
Project analysis and design. We have used 3 very common libraries: NumPy, Keras, and OpenCV. NumPy, it is a library for Python programming language, and it adds and it supports large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. And Keras, it is an open source neural network library, and it is also written in Python. It is capable of running top of TensorFlow, Microsoft Cognitive Toolkit, R, etc. And it is designed to enable fast experimentation with deep neural networks. And it focuses on being user-friendly and extensible. Third is OpenCV. OpenCV is open source computer vision library. It is a library of programming function, and it mainly aims at real-time computer vision. This is our data flow diagram. I will explain the diagrams directly with this one. First, the computer, it captures the actions from a live feed, we'll turn on our camera and we'll do the live sign gestures. The computer, it will capture the actions, it will process it, and the video, it will break the video into small frames. And each frame, it will have segmentation images. So what will the system do? It will compare those images with the training we have already given our system. So it will compare the images with the trainings, and if it matches, like I did a sign for hello and it matches with the training of hello, so it will display the output as hello. And that text, we can also convert that text into speech. So it will also speak hello. This is our methodology.
For methodology, we will explain it in 4 parts. So first is image acquisition from camera. Camera is the input device for our SLR as we acquire the required sign for the system. Then there is ample research going on in the field of sign language recognition. Researchers create standard database of signs and made available for fellow researchers. As in the reference, I've given the reference of this paper as Sulochana Nagveri, Dr. Arun Kumar mentioned in their survey. Standard dataset is available for following languages like American Sign Language. There is Kaggle, ASL Lexicon, and video dataset. These are fixed datasets which we can use for American Sign Language. Then also there are similar types of datasets for German Sign Language, Australian, Brazilian, Spanish. IITA, Robita, ISL is for Indian Sign Language. But there are so many sign languages for which standard dataset is not available. And for those sign languages, researcher creates their own database for training purpose. Like Tamil sign is created using web camera using 5 signers, as no dataset is available for Tamil Sign Language. Same as for the Science World, ARSLDB is an image and video database that has been developed by the authors for Arabic Sign Language. The dataset contains manual and non-manual sign performed by 10 signers, and similar for Bangladeshi and Swedish sign languages. Then second is hand region segmentation. Hand gesture plays a vital role in the sign gesture recognition system, since rest of the steps depends on the result of the step. Due to improper segmentation, the system fails to give correct result. Image with background and without background is captured separately. Then image is like we are using YCRCD, which can capture separately the image with background or without background. And HSV and the binary images are then added to get maximum result. This method gives better results even if there is a drastic illumination changes and cluttered backgrounds which does not require background subtraction. Y CGCR color space is illumination invariant. Secondly, the Y channel extracts the features of gray image, which can reduce the amount of computation. The YCGCR color space has strong skin color aggregation. The CG and CR components, they can effectively distinguish skin and non-skin color, so that system can only focus on the object with skin color, so that they'll work a little faster and more efficient. The advantages of this method is high locating accuracy and low computational complexity, which is more suitable for the hand gesture recognition.
Next is hand detection and tracking, and hand posture and recognition. These 2 steps I will explain collectively as feature extraction. Okay, so how our input images or the frame or the live feed that we are providing our system, it is not just our hand or the signs that we're giving, it has other objects in the background which are not needed for our gestures. So what will feature extraction? It is a process of extracting all those features. It will remove all them. How it does that? It will reduce the dimensions and the contents of the input image, and it retains only those features which are unique for each sign, and it is essential for recognition. It is a very essential pre-processing step to pattern recognition as well as machine learning. Like, for example, if the system, it sees my left hand or my right hand or my head, because in Indian Sign Language, we touch our head a lot to, show different signs. So if it sees these 3 areas, it will only select these areas and it will remove the other areas. And also if it also sees the color and intensity and texture, like my hands and my face, it is of skin color. So it will see all those colors when we provide the video or the live feed, it will see those colors, and rest of the colors like green and yellow, it will remove those colors. So that is how feature extraction works. Next is classified gesture. Once we have like extracted our features, we need to classify them. Classification, it is an important process in sign recognition system, as it takes the features extracted as an input and recognizes correct gestures. This process identifies to which category the given sign gestures belongs. Like if I did a hello sign, so it my feature extraction will extract my hello, like my sign, and then classification gesture, it will compare our gestures with the training we already gave it, and then it will identify which category the gesture it belongs to, and then it will put that gesture in the respective category. And it is done on the basis of training set of data of the observation. The few classifiers that we've used, or the very known classifiers, are support vector machine, SVM, knife based classifiers, ANN, artificial neural network, hidden Markov model. If I'm using, let's say if I'm using the hidden Markov model for Swedish Sign Language, so the research or the already given research on this paper, hidden Markov model for Swedish Sign Language, it shows an accuracy of 89.7. Indian Sign Language, if I'm using SVM, it shows and I have like 21 gestures, it shows like an accuracy of 95.30. This is how it works. Next is applications. Sign language recognition, it has like many applications. So we've just mentioned one or two here. We can use it in many places, like we can use it in hospitals and clinics, because if some person who is hearing impaired or vision impaired, if they want to converse with another person who is also hearing or vision impaired, we need a source, because it is a hospital and they need to be able to communicate properly. And the next application is like reception desks of hotels and offices, etc. So our conclusion, I'll just read this because it is very plain. In this project, we proposed an idea for feasible communication between hearing and vision impaired people, and also people with ability to hear and see more compared to the former, with the help of deep learning and machine learning approaches. These are the few references that we've used for our project. Thank you.
Any questions from the panel?
Have you included the database science in your PPT anywhere?
Ma'am, we have not put it in the PPT.
How many you have implemented?
Since we don't know sign language, so we've only implemented the basic ones like hello and thank you and I love you. We have a sample video if you want to see.
So no, how many signs? Only 3 signs we have implemented, because lot many you can design at your own, or existing database you can use, and you can design at your own also, because this is a project you are implementing.
Yes, ma'am.
So only 3 sentences we have done.
These are the only 3 we have trained our system in, and we want to learn sign language so we can train our system more with more words, but we can also use existing data sets.
And your results are ready?
Ma'am, since my teammate already said, we have divided a project into 3 modules. So our modules individually are working, but we have to, we are now creating a front end for it so that we can compile our modules together. So only the front end part is left.
Okay, yet interfacing is to be done and results are to be. Okay, so
individually, all the modules are working 100%.
Okay, interfacing and final results are yet not done.
Yes, ma'am.
Okay.
Yes, ma'am.